Good afternoon, everybody. I'm going to show a bit of work from each of my teams. As Scott mentioned, I have a team in Toronto, the Complex Systems Research Group, and then a team in New York, which is called The Living, which is a design firm that does innovative things, including our new Toronto office, which is on the screen there, in the Mars building. So that's our recent project that I'll talk a little more about later, because that fits into my evil master plan for sustainability. The talk is based on a play on words on the famous book by Stuart Brand, How Buildings Learn, and on the cover is a couple of buildings and how they changed over 150 years to better suit the needs of the people that inhabit them. And that's great. The buildings are getting smarter, but I need us to get smarter. So the goal I have is how buildings can teach us how to make buildings better. The reason this is important is because of sustainability. A lot of people talk about sustainability, but I think very few people have a deep understanding of what that means. And just curious, how many people have ever seen this picture, this graph? Good, two. This is basically a picture of sustainability. This is there's no better picture that I've seen that describes what is sustainability. And this is from a massive report from the United Nations. It's like reading 3 PhDs, and they have the important factors there: global warming potential, land use competition, and human toxicity, and those are combined into their environmental cost to the planet. And as you can see, it's dominated by animal products by a third, crops and coal, and this is. Make no mistake, this is the problem, and so we really need to address this. And of course, a vegan Vancouver would be the biggest step we could make on that. We don't need to invent anything or think about anything or have any meetings or anything. We could just do that. But in lieu of that, we have to move on to the other things where we can develop something. In part of the confusion about sustainability is that typically we only talk about the atmosphere, the top right part. And there's these other parts of not just pollution of the other parts, but destruction of the other parts. If we zoom in just to that atmosphere part, where we talk about CO2 equivalents and so on, there's another complex system here, that's how I named my group, just about the atmosphere. And this is from the same report. And you can see there's many interacting factors. The yellow block is the human impact. And so if we drill into that a little more, we can see, like, I like to put up this question, like, what are the top 3 sustainability problems just in terms of the atmosphere, not all of the environment, that was animal products. But if you look at the greenhouse gases, water vapor, CO2, methane, nitrous oxide, ozone, CFCs, the top 3, people typically think cars, right? Like, oh, I gotta walk to work and ride my bike and stuff. But of course, buildings are the number 1 problem in terms of the atmosphere. Animal products goes from, if you look at all the environment, from number 1 to number 2, and all of transportation. So not just cars, as I've drawn in my little funny bar chart here, but planes, trains, ships, everything is only 14%. Unfortunately, buildings are not working with us to help us teach anything. So I call it the reluctant teacher. The building on the left is in Toronto. It's Robarts Library, and people have complained about it for a long time, but it has a job too. Its job is to protect the books, and in particular, the block at the front is the Thomas Fisher Rare Book Library. And I don't know if you've ever been in there, but it is pretty cool. There's only the indirect lighting from the windows above. You can't take out a book. They bring you the book, and you can't touch it. With their white gloves, they'll turn the pages for you. The building on the right, that's another story. It taught everybody pretty quickly, I think. Part of the teaching difficulty is that while we might have great design aspirations, as it goes through construction and by the time it's operating, typically the performance doesn't go up. Almost never are we surprised that our building works way better than we had planned. And so the question is, how can we at least get back to zero? And then could we make further improvements beyond that? And that itself is a complicated part, but and it only gets more complicated if we consider beyond continuous commissioning of the mechanical system, continuous improvement. The complexity rises, and not just on the outside of the building. This was our previous building in Toronto, the 210 King building, but also on the inside, of course, there's the mechanical, electrical, lighting systems. These are all their own complex systems. And not just at the whole building scale, but at every scale. And this is some sensor work we did in the project that we documented on a website called digital210king.org, where we put all the files as well and everything, laser scans of the building, everything is there. And if we get down to the bottom scale, this is a slide that was recently given to me by Cliff Harvey. In terms of how buildings learn, if you look at some of these signs, it's just kind of crazy in this hospital, where it says if you haven't been seen within 10 minutes of arrival, that's probably why the clock is there. People are treated in order of priority, not time of arrival. Yet there's a ticket sign there that means that your number is called in order, not in priority. If the triage nurse is not available, please ring the bell. There's a little doorbell there. But then triage nurse, that sign, I guess the nurse is supposed to stand there maybe, and the little yellow sign says go to the designated area. Like maybe I wonder where that could be. So yeah, that problem exists at every scale. So what I'd like to propose is, and this is sort of my 20-year plan for sustainability, is that we move towards sort of a software development model. How many people have seen the V model? Validation, verification. It's something we use in software development, especially in critical systems, nuclear power plants, or airplane control systems, and so on. And the reason there's a few good ones like this. This is just off the internet, off the Wikipedia page. And it can map, you can see how it can map to AEC, so architecture, construction, and operations along the three axes there. And the interesting thing in these kinds of diagrams is how far along do we get in AEC? And I sort of claim that we only get past the verification. We answer questions like, do the individual building modules behave as per the design? Does the integrated systems behave as per the overall design? But we're missing the blue parts. And so my team, my two teams have been thinking about this and how to address these things to really see if a system meets the needs. So I just put this in here because I'm originally I was born in Denmark, so this is the Black Diamond building in another library in Denmark. And I use this as a metaphor of the black box. How can we open the black box? How can buildings teach us instead of just sit there and evolve as per the occupants? So to open that black box, I propose that we have, as we do in software, we have a debugger. Software is very complicated. It's insanely complicated. You're going to have millions of lines of code, and by definition, each line is supposed to be unique, because if you have redundancy, you make a function, and then you call that. And so in a building, we imagined what would that look like? What would a building debugger look like? Here's a software debugger, and it has different windows, and you can watch variables and see which functions are being called. And so I was inspired by this picture in 2009 or so, which is a building on the University of Copenhagen campus called the Green Lighthouse. And I thought, oh, this really shows me how the building works. Like, could I have something that's based on the building information model that can convey this kind of information? And so in 2010, we showed Dasher, which is a building dashboard that was our first step towards that, and there's a number of features in there, and we worked on that for quite a while, and we built a detailed model of our building. This is sort of an as-built, this is a heritage building. It's kind of a best case, worst case scenario because it's 4 old buildings stuck together, and each one had their own things. They're not even all aligned, and having a ground plane is difficult. So it was a good learning experience this is how we learned Revit, is doing this. Now we've moved into our new building in the Mars Center, the Discovery District, and I'm super happy to be there. This is a great ecosystem, and if you're in Toronto, I welcome you to come by. Just bug me, and I'm happy to show you around. Of course, we're running Dasher on the new office as well. We're just starting with this, so I don't have too much information yet. When we plugged into the building control system, 700 sensors showed up, so that's a good start. But as with most projects, half of it is seem to be from another tenant, and so there's a debugging part itself, and that reveals the sort of the thing about Dasher is once you start looking at the data, that's the only way you can actually figure out what's going on. Here's a top view. I think this is the CO2 from the CO2 sensors that are just part of the building control system. We didn't add any sensors to this building yet. And here's a short video of our old building. Hopefully this is playing. Or not. Oh, now it's playing. Almost. There we go, the other play button. Not playing. Well, it was extremely cool. You would have loved it. Okay, we'll just move on. This one's playing a little better, hopefully for you. This is the NASA Sustainability Base in California, and they have a really good density as a smart building or a living lab building as well. They continuously try to improve their sensor types and layout, and this also reveals interesting things. The bottom right corner of the building, that was interesting for them. They were wondering, why is it having that response? And they remembered, oh, that's the room where we put some special glazing as an experiment, and so they could see it in the data there. This is our Pier 9 facility in San Francisco, where we also added cameras and some machine learning to look for occupant events. I don't know if you can see on the blue timeline at the bottom, we're doing some computer vision analysis to find out when something interesting is happening on the bridge. And we've can synchronize that with all of the other sensors to look for events. This is part of a little mini infrastructure project that we're playing around with, mostly to investigate the computer vision possibilities. In construction, last August, we started working with a few companies. Pillar Tech, this is a sensor box that you can strap onto a pillar to see what's going on in your site before those kinds of sensors are physically installed. Triax is a sensor worn by the workers. It can detect slips and falls, but also you can sound an evacuation alert and see which zone somebody's in. And then Versatile Natures, this is a company that's tracking the crane as well. And so we put it all together, also in Dasher, to visualize what's happening on the construction site. So it's interesting that, the things that we did sort of for operations and seeing how the building works can also be used in helping out during the construction time. There's many more things that we can do here. This is just our first steps into construction tracking. Well, actually, we have a few more things. I don't know if you're familiar with phasing in BIM, in Revit. You can have these different construction phases. We can also visualize that construction process going on. I should have been narrating here. This is the people leaving when an evacuation button has been called. There's a zone on each floor and then 3 zones across the floor plate. And finally the crane data. So the first data that you saw, that was the Pillar Tech data. And it also reveals, I was wondering, why is it doing that crazy thing, the crane? And it's because we're missing the context. This is where I'd like the cameras now to see oh, it was avoiding some other obstacle, or maybe there's another crane there that we're not tracking, things like that. So it does, by looking at the actual data, before even doing any machine learning or any interpretation, this kind of tool can help you understand whether your data is good to start with. So going back to this chart, and specifically these two questions, this is the second half of the presentation. So I wanted to show you something about collecting real data from a system to build confidence that you understand how it's working and whether it's working correctly, whether you're collecting the correct data. And then the second part is the validation part. And this is the missing step, I think, in most projects, where we just, it's hard for us to go back and talk to the end user, the occupants, and even more high level than that, the actual business goals of the stakeholders, which also, of course, change over time. And this is where we can include sustainability in these two parts as well. So the next part of the talk is Project Discover. This is the name of our project for generative design in construction, in AEC. And this is the process that we developed for designing our new office in Toronto. So it's 2 floors. It goes the length of the building there to the right and the left of that block. Most of the research group is actually in that block section at the end towards us. There's a few other people in the team, including one in here in Vancouver, one in Switzerland and so on, and a few people in San Francisco as well. But the bulk of the research group is in the Toronto office. The generative design process is sort of a level above our current practice, where we try to describe the project in more abstract rules and constraints and goals. And so by doing that, we can look at how we can generate a BIM or generate the design. And based on these higher level things, this is very similar to what Mark was showing this morning. And then through different optimization methods, we can evolve the design and have an optimization search through the design space to find the candidates. And we can evaluate all of those designs based on our set of metrics and goals and constraints that we set up. And then we can select one and then refine it and build it. Oops, wrong way. But the process started with gathering data. So we're in the unique position that we already know who's going to be in the building. We know exactly who they are, and we can ask them, who do you work with? What kind of work style do you like? Light or dark, active or quiet, and things like that. We can overlay the org chart and say managers should sit with their team when we generate a floor plan. We can ask managers which teams collaborate, which should be close to each other. We can ask individuals and teams which services they want to be close to, like the workshop or the entrance or the kitchen or whatever it is. And then we can develop a number of systems. In this case, this was our neighborhood metaphor system. And we can just generate lots of designs. And then the little spiderweb thing there shows how well each design performs on those different metrics. We have low distraction, we have adjacency, interconnectivity, daylight, views to the outside, and work style. Daylight is the only sort of traditional simulation we're doing there. And so the thing that makes this fun for me is that we're taking these sort of traditional fuzzy concepts and we're trying to encode them into the system. And that's why it's called Project Discover, is to help us discover things that we wouldn't otherwise. And this kind of started because in one of the early meetings, where people were talking about that, like, oh, well, we should be close to this, and that guy should be close to them. I stood up and said, like, we need to write some software. This is unmanageable. In this project, we ended up with 6 goals and constraints. So each one has a visualization, so we can, again, understand how it's working. And each one scores a specific design. So the system generates a design based on the parameters given to it from the optimizer. And then we evaluate that design on how well it performs. We evolve the design. We generate lots of things. This is a genetic algorithm. And so some are selected in each generation. and they're mutated into further designs. And this is the one we selected finally, and then we built it. So again, I welcome you to come by and see the office. It's interesting to go around in the office and see the different neighborhoods and see how some of their selections are reflected in the office. On the right is the research area, where we have the students in the middle and these mini offices we call cabins around the edge. And but other neighborhoods have completely different work styles and work preferences and things like that. There's two parts now of how this building can teach us. There's the qualitative part and the quantitative part. And the gray ones are the ones we used in this project, but we'd like to expand that, including other standards like the WELL standard and things like that, encoding them into the system. So we can measure a design, how well does it perform on both sustainability things and wellness things. That would be ideal. And the bottom line is by automating enough of these things, we can actually make it cost effective and usable. So we have the quantitative part where we collect data from the sensors, and then we have the quantitative part, sorry, I mixed that up again, qualitative part, which is the app. So together with our office, we made an app called the Workplace app. And this is designed to survey people, hopefully not interrupting them too much, with little questions here and there along the way to collect their feedback. Of course, we want to make it useful for other purposes, and we want to take advantage of the fact that we have a building information model, so we can include booking rooms and showing schedules and showing a map of locations. This is the same Revit model that we've reused in our Forge viewer, so that we can just show the floor plan here as well and put the desks. We've overlaid this with, again, our org chart and we use Workday for our HR system and things like that. So there's really a bunch of services that come together into this app. And this is again, the teaching part, where if we have generative design and we have encoded our metrics and our goals and constraints, we can have a system where we generate a design, build it, monitor it, take feedback continuously from the sensors and from the people, and every night we can just generate a new design and see, is there a better design that currently meets the business needs of all the people working in that space. And then, this is the last slide, I think. If we can include the cost information of a reno, whether we decide, at 3 p.m., more people need a meeting room for 4 people than this 8-person meeting room, and you should split it, and it would cost this much. Or these two teams have started working together. It's like Mark's machine learning stuff. We can watch Slack and see that, these teams are collaborating now. It would increase productivity if you now move these two teams so they're sitting close together. Once we cross some threshold is crossed that you're interested in, then the system can report this to you. And talking to Brad earlier, I was saying the example of a variable speed pump, so that these have a higher cost than the old ones. And so it would be great if you could have some system that told you, like, now it's actually worth it for you to install this device. It would cost this much, but we could hook that up to a green financing company as well, and they could say it won't actually even cost you anything, and they'll share in the profits and so on. So hopefully I've shown you the two parts that is part of my vision, to have buildings teach us how to make them better so that we can integrate both real quantitative and qualitative data to make sure that we don't end up with what we had before in our old office and what many offices have, which is just a building that everybody dislikes. So hopefully we're moving in the right direction. Thank you.
Thank you, Azam. You beat me to it. Very interesting presentation. Thank you very much.
Thank you.
Do we have any questions from the audience? I have a quick question that may be a little off topic. makerspace that you had in the Toronto office, when can we get one in Vancouver?
That is a good question. That is a good question.
Because it's great to have a space like that, and especially coming from Autodesk, where you've got the software with the machinery, developing those problems, and the feedback that you get from those types of facilities. Would love to see it here in Vancouver, that's for sure.
Well, hopefully we'll start working together soon because of this meeting, which is great.
Yeah.
I've already had some great conversations with Helen and others, so I hope we can move in that direction. We have a number of employees here, but we don't even really have an office here, so
Yeah.
I definitely am all in favor of collecting that effort and putting it in the context. I really love the Mars space and the idea of this sort of innovation hub and district. It really brings excitement to an area, so if we can create something also like we saw in the Netherlands, these kind of spaces,
Yeah.
together with startups and students and equipment and the software, I think that would be fantastic. I agree.
Yeah, awesome. Another quick question for you, and once again, anybody from the audience, feel free to ask a question. I know Autodesk has a really good, strong engagement with students. And what kind of uptick are you seeing around this level of technology with your students? Because I know, obviously the applications, Revit, AutoCAD, those types of applications. So what about the computational aspects, and what kind of engagement are you seeing there?
There's all kinds of different parts going on. We're talking to George Brown also in Toronto, and the new
Right.
School of Architecture at University of Toronto, which is a beautiful building as well, with Brady Peters there. So we're seeing also them building these kind of spaces with all the robots and everything, and the students really getting more, or I should say, honestly, it comes from the professors, right? So the professors are becoming more computationally minded, and they're
Right.
really encouraging their students to develop those skills. So that's great to see as well. So it is going forward for sure, at least in Canada, and I'm familiar with the folks at CITA in Denmark as well. So they're also pushing these kinds of things ahead. But of course, there's no shortage of more things we could do.
Yeah. No, that's right. Certainly appreciate the work you have been doing with the education community, that's for sure.
Thank you so
Very
much.
good. Thank you, Mark. Oh, Azam.
No problem. Thank you.